Hello, everybody. Looks like we are ready to go here. And I have Stefan Bockel joining me today. So I'm Amelia Thompson, going to be your host of today's Würth Elektronik webinar. I want to make sure that everything is up and going. You can hear me. Some of you can even see me. This is great. So today we are going to be learning some really cool stuff. On today's webinar, partnered with DigiKey Electronics, we are going to be talking about the processing through-hole components in the Reflow Oven. It's everything about THR soldering. Again, our exclusive sponsor, DigiKey Electronics, and presented by Würth Elektronik's own Stefan Bockel. Now, Stefan is a field application engineer in our electronic interconnect and electromechanical division. He is everything connector extraordinaire, if I do say so myself. Stefan, do I have that correct?
That's correct.
Awesome. Now, if you have any questions during today's webinar, please feel free to ask them in the questions box. We're going to be answering them at the end. You can go ahead and test out that questions box, give us a greeting, give us a hello. I don't know about you, but it's 9 o'clock in the morning here in South Dakota. I know some of you are on the West Coast. It's a little bit earlier for you, so hopefully you have a nice big cup of coffee to get you energized for today's webinar. As a reminder, because you registered for today's webinar, you are going to automatically receive the presentation slides and the video on demand when they become available. It might take us about a week, but we will be getting you that video on demand. Simply look for the link in your email. And don't miss out on our next webinar on May 10th. It's retrofitting for industrial IoT using Wi-Fi. That's right, retrofitting for industrial IoT using Wi-Fi, partnered with DigiKey Electronics, and you can register online at www.we-online.com/webinars. And now let's begin today's Würth Elektronik webinar with Stefan Bockel, processing through-hole components in the Reflow Oven. It's everything about THR soldering, partnered with DigiKey Electronics.
So thank you very much, Amelia. Good morning, America. Good morning, Canada. Yeah, good afternoon, Europe. Hello to the rest of the world. Thank you for joining our webinar today at Würth Elektroniks. My name is Stefan. I work as a field application engineer since 11 years now in the company. And the topic I have today for you is THR through-hole reflow. So this is a topic how to process through-hole components in the reflow oven. During the presentation, I will also switch off my camera so that you can concentrate on the presentation. But after the presentation, we will have a Q&A session together, and I will switch my camera on again. And we can go ahead for your questions. You have questions which will occur during the presentation. So I just switch off my camera and start with the topic. One moment, please. Okay, I hope you can see on my screen. And then we will start with a small agenda. What about we are talking today about why do we need THR components? Then we are talking about the requirements for the products and the basic materials. So you cannot take a THT product, a through-hole product, and go through the reflow oven without any issues. So there have to be some changes made on the plastic material, made on the housing. That's the point we have to look at, point 2. After that, we will go for the layout and stencil suggestions for THR soldering. And then we will have a look at the process and the stages of the process. And at point 5, we will have a look at the IPC quality requirements regarding the solder joints occurring due THR soldering. And point 6 is the advantage of THR. And at the end, we will have a small summary about it. And of course, the last point is your questions. I will try to answer all your questions immediately. If it's not possible, I will try to answer them by email. Okay, let's start into the topic. So when we look a little bit behind at the 50s, the first PCBs came up and all the components we had on our PCBs were through-hole components. Components were pushed through the PCB and soldered on the downside of the PCB, either with a solder iron or with a wave technology. So this is a nice system and it has nice features, but the components are very big and also the PCBs were very big, so we want to create smaller PCBs. Therefore, we needed a new technology. This came up in the 80s, and it was the SMT technology. You all know the SMT technology. It's called surface mount. All the components are mounted on the surface of the PCB, just sticked on a solder paste, and then gone through the reflow oven. So this is very a nice system to get more components on the smaller PCB. So the PCBs get smaller and smaller, but we still have some connectors on the PCB. And when we look at the connectors, we have to take care about the insertion and withdrawal forces. Because when you apply too much force on a connector, which is just SMT soldered on the surface of a PCB, you can imagine you can lift it off, you can destroy the PCB, and the application won't work anymore. This is what we want to avoid. So we need another solution for the through-hole for the components, for the big components, for the connectors. The solution is THR through-hole reflow. That means we have a through-hole component which we can solder in the reflow oven. Another wording for this is PIP. Perhaps you heard sometimes PIP. This means pin in paste, because we have the solder paste on top of the PCB and we stick the pin inside of the solder paste, and that's also the same terminus for the same technology. It's PIP and THR, it's just the same. So now we have a look at our components themselves. As example, I will take a connector, and we have to change something with the housing and the pins of the connector, as we can see here. What has to be changed for a THR item? First of all, the housing. Not only the material of the housing, because there are higher temperatures in the reflow oven, also the dimensions have to be changed a little bit. Why? I'm explaining soon. And also we have a look on the terminals. The terminals, the contacts which go through the PCB, they have also to be a little bit modified. So here you can see on the left side a normal THT product. This is just a terminal block as we use it for power on the PCBs. It's a through-hole component and normally soldered by Wave. And when we look at the right side, we see the THR component. You see it's a different plastic material, and it's also a little bit different shape of the housing. Why do we need a different plastic material? Why do we need different shape of the housing? In the reflow oven, we have higher temperatures than during wave soldering. So the temperature can go up to 260 degrees Celsius. And that means we need another plastic material. We often use the LCP material. LCP means liquid crystal polymer. It's a special plastic material which is very rigid. It is very high. It has a very high temperature resistance, and it has no deformation, easy to place, no difference between the part and the pitch of the PCB. What does this mean? It has exactly the same expanding coefficient as FR4 material in our PCB. That means when we go into the oven, both gets warm and shrinks in the same value. So, and this is really a good thing when you have a high pole connector like a 10 or 12 pole connector, because it cannot get damaged then through the soldering in the oven. And another advantage of this plastic material is the moisture sensitivity level. It's the MSL1. MSL1 means this plastic material does not take any liquid inside. So you do not have to take care about any liquids during storage of the component. You can just store it in a normal way and then solder it on the PCB. There are still other materials possible for the THR soldering process. Some polyamides are also related to high temperatures, like for example the PA9T material. But with the polyamides, we have to take care about the moisture, because the moisture content must be watched, and those materials they take the moisture inside, and after that, if you do not dry them before you solder them, you have an issue regarding bubbles. As you can see here on the picture, some bubbles occur. Why? There is water inside of the plastic material, and when we go through the reflow oven, the water gets 260 degrees Celsius. It gets very hot, so it takes over to steam, and the steam wants to go out of the plastic material. So, and that's the reason why some bubbles can occur in the oven. So if you take a PA material for THR soldering, please take in consideration that you have to take care about the storage before soldering regarding moisture. Okay. Now we change the plastic material, but we have to change something else. We have to add something on our component. We have to add some small plastic pins. And those pins provide the necessary distance to the solder paste and to the PCB. And this is really necessary because we have solder paste on the PCB and we need a distance of 0.3 millimeter up to 0.5 millimeter. And the coplanarity should be less than 0.15 millimeter according to DIN EN 61760-3. And to allow a visual inspection, we also need those standoffs. Why do we need them? Because with a THR soldering system, there's a solder joint occurring on the top of the PCB. And this solder joint has to be controlled by the camera after soldering. This is only possible if we can have a look under the component. And if the component is stored directly on the PCB, it's not possible to have a good look on it. So to allow the visual inspection, we also need the standoffs and to allow the airflow under the housing. And this is very important, especially for high polarity components. And the standoffs are also good to have a solder paste depot under the component. It does not stick into the plastic material, the solder paste, it's just because of the standoffs. So we need some standoffs. We cannot put the component directly on the PCB. Here you can see the airflow, which is very important for high polarity connectors, so that the connector has the same shape on every side. After the soldering process, we need to make sure that the air can flow under the component. Therefore, the standoffs are also necessary. And through this airflow, also big components are THR compatible. For example, like our Red Cube series, for delivering power up to 85 amps to the PCB. You see, this is only a metal part, but it's still a THR. You can still solder it via the THR technology because it has some standoffs, as you can see here on the right side of the picture. So is this all we have to change? No, we have to have a closer look on the pins too. So that we will do in the next slide. So what do you think when you see a pin like that? Okay, this looks not really stable. This pin is a little bit short. With two short pins, the mechanical stability is not given. And according to the DIN, the pin should look out 0.5 millimeters out of the PCB. It's not a mandatory, but it should be like that because otherwise it's hard to control the soldering result after the soldering. And if the pins end in the PCB, the developer must say how the visual inspection works. So it's up to you when you have two short pins. And of course, the IPC A610 may not be met. But what is the IPC A610? It just says how a solder joint and with a THR technology should look like. Therefore, there are three categories for it. I will show you in the next slide. The first class are general electronic products, so no increased demands on the function. That means, for example, you have a toy like a small car for kids, and let's talk about the police car, and it has some LED on the top, and the LED doesn't work anymore. So this is not critical. It's sad for the child, okay, but it's not critical. So this is a class 1 component, the LED in a toy, for example. Then class 2 applications are electronic products with increased demands, like we have in the industry, in the industry field and the industry surrounding. There are products with a permanent functionality. Interruptions in the operation are not desired, but are not critical if they happen. So nobody gets hurt. There's no big issue if there is a small interruption of the component. And there are no special ambient conditions. Everything fine. And there are also class 3 applications and class 3 applications. I think a lot of you are dealing with class 3 applications. Those are high performance electronics, like for aircrafts or military or medical equipment. There, the products have to have a permanent function, and interruptions are critical, not accepted, and they can lead to any issues. And there can be some exceptional environmental conditions. So we have 3 classes where the solder joints are defined for. Class 1 is a lower one, and class 3 is the highest one. Let's have a look at the pin again. What happens if the pin is a little bit longer, or if the pin is too long? Then we also have a little issue, because the solder paste can be pushed out by the pin again. So you can imagine you have solder paste on the PCB, then you stuck in the component, and then you can push out the solder paste again, and the solder paste can fall off, or solder ball could be created, and there a visual inspection is difficult. So at Würth Elektronik, we use 2.6 millimeters pin length. Why? There it's suitable for the 1.5 millimeter PCB, the standard one, and also for the 2.3 millimeter thick PCBs. So our THR components are suitable for 2.3 millimeter thick PCBs. So now everything was spoken regarding the components and the changes we have to do on our components. And now we will have a closer look at the layout and the stencil suggestions. So Würth Elektronik offers also a Stencil-Calculator. You can download this Stencil-Calculator together with this presentation. We will give you a download link for that. But I still will explain now how to calculate the following points which are required for the layout and the stencil calculation. First of all, we have to have a look on the via in our PCB, and we have to calculate the via volume of our PCB, because this is the volume we want to fill with the solder paste. So here you can see the formula for the volume calculation of the hole, and it's regarding just the PCB thickness, the hole diameter, and the solder pad diameter we have on top of the PCB. Then we have to do a volume calculation of the pin, because we have to, we put the pin into the via of the PCB, and then the pin is inside. So we have to calculate first the hole, and then we have to calculate the pin and the pin minus the hole minus the pin. Sorry. So for round pins, the formula you can see here, it's just the shape of the pin divided by 2. If it is a round one, and if it is a rectangular one, you have the formula with a root inside. Then we have to take care of the solder joint, and the solder joint can occur when you look at THR soldering on top of the PCB. It's important that it occurs on top of the PCB. But there can also be a solder joint on the bottom of the PCB, and we have to calculate the material for the solder joint, for the so-called fillet. There you can see the Papus-Galdin formula to calculate the fillet. For round pins, again, for rectangular pins, again, the formula with the root inside. And we need a small free volume for the solder paste itself. Now we will go to the stencil, because there's also something special on the stencil. When we have a look at the stencil, we have to take care that we have a bigger opening of the stencil than our PCB hole is in our application. Why? Because we need some material to bring into the hole to get a good solder joint, to get a filling of at least 75%. That's what the IPC says. So we have to calculate the volume of the solder paste, which we need for the application. And this volume of the solder paste is 2 times the volume of the fillet plus the volume of the PCB minus the volume of the pin. That's what I wanted to say 2 slides before. And this we have to multiply by 2. Why? Because when we look at the solder paste, there is only 50% solder material inside, only 50% tin. The rest of the solder paste is something else, like flux and other components. So this is the right formula to calculate the solder volume for a stencil opening. When we look at the thickness of the stencil, we suggest a stencil thickness of 150 micrometers. It's always good to have THR components soldered in a proper way. So there you can see the formula to calculate the whole thing. It also, again, depends on the stencil opening, if you have a round opening or if you have a square opening. And for the round opening, it's easy, and for the square opening too. There you can see the calculation for the opening. But you do not have to do this in your application every time when you want to solder a THR component. Therefore, we have some Excel sheet for you. This is what you can see now on the screen. You just enter into it your solder pad diameter, your plated hole diameter, your pin diameters, the board thickness, the paste reduction factor is 0.5 because remember, it's only 50% solder paste in the material. And you have to add the stencil thickness, and after that you will get a proper result for the stencil opening. So this is really quite easy to calculate, and you will receive this Excel together with the presentation after our webinar. Okay, now we calculated the stencil opening, and there are some different stencil openings possible to do THR soldering. I will show you them in the next slide. These are the typical stencil openings for THR soldering. The first one is a round standard opening, the second one a rectangular one. And you can see here the corners are not sharp, they are a little bit round, and this is because that the solder paste cannot stuck on the squeegee when you do squeegeeing solder paste over the PCB. The third one here is necessary when you have to overprint something. That means if your PCB is, for example, a little bit thicker, then you have then you need more material into the hole, and therefore you have to overprint a little bit. You can do it like this, and also have round corners because of the squeegee, that the solder paste is not stacking on the squeegee. The fourth and the fifth one here on the screen is just for components which have to be printed on both sides from the PCB, on the top side and off the bottom side. And here you can see the possibilities for the bottom side. Okay, now we saw the stencils and the stencil openings, and we will have a closer look to the process itself. The process itself at the stage of processing, it's close to the SMD components. It's the same thing as we have when we have surface mount technology. We can do a full automatic assembly, and we can solder in a reflow oven. First of all, we have to do the paste printing. After that, a little inspection. This can be done manually. This can be done with an optical inspection. And then we have the pick and place machine. And after that, we have also a so-called manual placement. And this is when the component gets too big. For example, a 12-pole connector, it's not easy to bring into a belt. So it's not possible to do it with a pick and place machine. You have to do a manual placement for big components, just in between the pick and place and the reflow oven. And then after our components are on our PCB, we can put it through the reflow oven, and everything is working in the proper way. After that, it can be inspected by the AOI, by the automatic optical inspection system. So the first step is the screen printing, the paste printing. It works automatically with a squeegee, but you can do it also by hand with a squeegee. And those are the steps we have to do. First, we put the stencil on a PCB. Then we go put some solder paste on it, go over it with a squeegee. And then the solder paste is in the stencil's aperture. But what we have to take care about are the solder balls. This should not occur, because then the solder paste will get pressed out again of the PCB, and this happens if your pin is too long of the component. But we already chose the right component, so we do not have to take care about too long pins. After that, the pin is getting stuck into the PCB, and in the reflow oven we can solder it, and on the best way we have a result like that. So there you can see we have 100% filling of the via. This is not normal. Normally we have a in between 75 and 19% of a filling, but this is a perfect solder result, as we can see here on the screen. The next step is our pick and place machine. And this also, it's a little bit different. It also depends on your pick and place machine, how big the components may be. So some machines are suitable for big reels, some machines are only suitable for smaller reels. So you have to take care of on the machine which components can be placed with an automatic machine. Therefore, we also add some pick and place caps on our components so that the nozzle is able to take the component and set it on the PCB. And there you can, at this point, I want to tell you that you can imagine that the THR component is more expensive than a THT component. First of all, we need a better plastic material. Then we need an additional plastic cap, and it also has to be on this high temperature material because it goes together with the component through the reflow oven. And altogether, this is much more expensive than a cheap plastic material. So that means that the THR components are always a little bit higher in price than normal THT components. But when you look at the end, you do not have to go over the wave soldering machine. You do not have to do a selective wave process or external soldering process again. You can do the soldering in one step in the reflow oven, and there you will save the money again for the little bit more expensive component. So, and if it's possible, we deliver our THR components on a reel, as you can see here. And it just depends on your machine how big the reel can be to use it for a pick and place process. And then we go into the reflow oven and have a look at the reflow profile. So the reflow profile, it's close to the reflow profiles we have for the SMT products. It's just the same profile, and it also depends on the package thickness, the peak temperature. It's just the same as we have with the SMT components. So to get the right solder profile for your application, you should take the biggest component, normally it's a THR component, and compare it to the smallest component and set up then the proper soldering in your oven. So I have some examples for you. So this component is soldered, but it's not soldered in a good way. So as you can see, it's not filled to 75%, or it's just filled on the left side. The right side, it just touches the PCB. So this is not IPC conform, but let's have a look and see what is IPC conform. Therefore, we look at the IPC itself again. And here are the quality requirements according to the IPC for non-plated holes. But this is not the case we have. We do not have non-plated holes. We work with the THR technology with plated holes. So this means our meniscus does not occur on the top, on the bottom of the PCB as it does when you do wave soldering. It's just on the top of the PCB. Therefore, we need another table. It's just this one for plated through holes. And there you can see that the solder joint must have, for class 1 components, for class 1 applications, 270 degree. On the bottom side, there has to be no solder joints, not necessary, and the filling is not defined. So it's okay if it just touches the PCB and it just works. For class 2, it's a little bit different. We have also the 270 degrees solder source and 0 degree on the bottom of the PCB, but we have to establish a filling of the via of at least 75%. And when we look at the class 3 applications, it's higher again. There the solder source has to be 330 degree and the filling has to be also at least 75%. So what does this mean? When we look at the pin and the PCB themselves, you can see the top one is 100% filled and this one is 75% filled. And you can see there is no solder joint on the bottom of the PCB. It's not necessary for the THR process. It's necessary on the top of the PCB. And then we need again the standoffs to do a visual inspection of this solder joint which occurs on top of the PCB. As you can see here on the picture, when we look at the IPC, the plated through hole must be minimum filled to 75% with solder paste. And I've got also some good examples for you. Those are perfect soldering results with the THR soldering system. The first one is 100% filling, as you can see. The second one is around 95%. There is just a small bubble inside. This can occur if some bubbles are in the solder paste. And the only thing to avoid such small bubbles in the solder joint is to use a vapor phase with a vacuum, but this is really complicated and only necessary for special applications like military applications or space applications, which you cannot repair. Okay, some other examples for you. What do you think? Solder quality on the second look are the following examples IPC compliant. When we look to the left one, I think it's easy to say, no, this is not IPC compliant because the filling of 75% is not there. On the right side, we just touch the PCB, there's no big filling, it's not IPC conform. And when we look at the right one, we can see also a big soldering, and the soldering is the solder joint is very big at the top and at the bottom of the PCB. But when we look at the via, then we see that the via is much too big for the pins. So there, the dimensions of the via and the pins are not correct, and this is the reason why this is also not IPC conform. So now I will show you some IPC conform solder joints, like this one. Or the next picture, it's easier to see the component itself. There we have the pin, which goes into our PCB, and it's soldered on a perfect way on the right side to the PCB. On the left side, there is no tin inside, so this is no soldering on the left side. So this one is not IPC conform. This one has the same issue. On the left side, we have no tin. On the right side, it looks okay. We have a small lunker inside, but this doesn't matter. This small bubble is still okay. But here we should have some tin on the left side. So this is also not IPC conform. And the next one is just a perfect THR solder joint. Here you can see the perfect solder joint. We have a perfect connection to the left side of the PCB and all layers inside of the PCB. Here you can see this, the first layer, the second layer, and the third layer. And also on the right side, we have a perfect soldering result to the layers, to the first and the second and the third layer. So this is a perfect solder joint regarding THR soldering. Okay, now we have to talk about the advantages of THR. Like THT, THR resist mechanical stress. So a much more better holding forces for the big components. If you have a through-hole component which goes through the PCB, it has higher mechanical stability. And this is useful, for example, for end user interfaces. You do not know what the people do outside. They put in, for example, when you look at the RG45, they put in the cable, and there's a locking system inside, and if you pull on the cable, you can destroy the PCB if the component is just mounted on the top. So in this case, it is better to have a THR component. Like SMD THR, it can be soldered in the reflow process. You do not have to have an additional process like wave soldering or selective wave soldering. It's not necessary anymore. This saves production steps. And if you save time, normally you should save also some money. And that's the reason why THR is coming up more and more, and it's more and more interesting for our PCBs today, because we have the high mechanical stability and we have only one soldering process, and we save time and money. So when we look at the summary, you can see that the dimensions and the material of the housing must be changed to have a proper THR component. The pins have to be made shorter. And yeah, it combines the advantages of the technologies from SMT and THT. So the mechanical forces of THT and the soldering of SMT. It can be soldered in a reflow process, and the manufacturing process can be optimized with THR components. So it saves time and money. I hope you could enjoy this nice webinar, and now I'm open for your questions. And I also will switch on my camera again, that we can talk about the questions which came up. Thank you very much for listening.
Thank you very much, Stefan, for presenting today's webinar. We do have a few questions rolling on in. We're going to get to those in just a second. Again, if you have any questions, feel free to message us in the questions box. And if we need to go into detail, or maybe we don't get to your question today because of time constraints, no worries, we will answer them through email. Simply look for our email at webinarteam@we-online.com. All right, here's one of our first questions. Can I also use THR technology in a vapor phase? And is there any setting that you need to change?
Okay, thank you for the question. This is a really good question. Yes, you can use the THR components also in the vapor phase. You have just to respect the same things as in the reflow oven. You have to respect the normal vapor phase profile you use for the SMD components. You can use the same profile for the THR components, and they will be soldered in a proper way. It's very good to use a vapor phase for THR components. Especially if you have a vacuum vapor phase, then you can avoid the small bubbles in the solder joints.
Absolutely. On to our next question here. Can I use gold-plated pins for THR soldering?
I would not recommend the gold-plated pins for THR soldering. It's because of the wetting. The wetting is not so good as you have tin-plated pins on this on the component itself, and we have only a small time in the reflow oven to get the product soldered and to get the product wetted. And if you have gold pins, it takes a longer time to wetten the product, and the solder result may be not so nice as when you have tin-plated pins. So I would not recommend the gold-plated pins for THR.
That makes a lot of sense. Our next question here. Are all THR components delivered in tape and reel?
This is also a good question. Yes, we try to deliver all THR components on tape on reel, but sometimes, as I also mentioned during the presentation, you have a high polarity connector, and the high polarity connector gets very big, and there is no belt available for such a big connectors, and also the machines are not able to process some big belts like this. So for the high polarity connectors, we cannot offer tape and reel packaging. We offer them in a bag, and you have to place them by hand.
Okay, on to our, it looks like our fourth question here. This one has been really popular, especially with recent events. Is an automotive application class 2 or 3?
Automotive applications are class 3 for sure, because there you have to respect a lot of things, and it's always danger when the PCB fails. So, and this means you have a class 3 recommendation for the solder joints also.
Excellent. Yeah, automotive has become very popular lately. Our next question here, what is a typical solder paste thickness? Do you know?
A typical solder paste thickness for the THR processing is around 150 micrometers thickness. So you can do it also with 120 micrometers, but then you have to take care about the stencil opening. Then the stencil opening gets very big. So we recommend 150 micrometers. Then the soldering is going in a good way.
Absolutely. Another question that has come in, is there a tool for crossing parts from THT to THR?
No, there is no special tool for crossing parts. You just have to take care about the data sheet. So in the data sheet, it's recommended the soldering. If you read in the data sheet only wave soldering, you can be sure that it's only a THT component and that the plastic material is not suitable for the temperatures in the reflow oven. But when you read, for example, wave or reflow soldering in the data sheet, so at least at the data sheet of Würth Elektronik, this means you can take this product for THR soldering. It's suitable for the reflow oven too. So you just have to look on the data sheet which soldering options are mentioned.
Outstanding. We do have a few more questions coming in, and again, we were really hoping to get to all of them, but there are quite a few. So if we don't get to your question, no worries. We will answer them offline a little bit later. And
Sure.
for those of you who are asking about the presentation, it will be available when the video becomes available. So you'll be getting the presented materials and the video on demand within the next week. Simply look for an email from webinar team at we-online.com. Our next question here, is the THR joint just as strong as THT without the bottom, and here it's called fillet, but fillet?
Yes, I think I know what the customer means. So if it is still if it has the same strength as a THT component, which is soldered on the downside. Okay, it has the same strength because when you look at the THT component, there's no solder joint on the top of the PCB. And on the THR component, we can have a solder joint. We do have a solder joint on the top of the component, and we can have a solder joint on the bottom of the PCB. So sometimes it's we have two solder joints, and the let's say the force is even bigger. The holding force is even bigger than with the THT component because we have more solder material around the component and inside the PCB.
Our next question here, what are your recommendations of diameter of the through hole versus the pin diameter?
This just as you can just go take the same recommendations as you use for the THT soldering, the same holes. So this is highlighted in the software systems like Altium or something. You can take the standard one. There's no special recommendation for THR soldering. You have to just to take care about the opening of the stencil. Then again, that the stencil fits to the PCB.
Now this one is pretty specific to Europe, but do you make custom connectors with specific pin length for thicker or thinner PCBs?
Yes, we can always go for customized connectors, but it's just a question of quantity. So therefore we need for example, some tools, and we have to do some investment for the tools, and the quantity has to be around, let's say, 5,000 or 10,000 pieces, and then we can do a customized connector for THR, no problem.
We have time for a few more questions here. Are the connector parts UL certified?
Yes, all our connector parts are UL certified, and most of them are also UL and CSA certified, also for Canada.
Amazing. Our next question here, is LPC connector compatible with other plastic housing for the mate?
Yes, no problems. This is a standard application. There's often a situation that you have a THR component on the PCB, and you do not know who is manufacturing the cable on the other side, and it doesn't matter which plastic material the mating component has. So it fits also into the component on the PCB, even it's different plastic material.
All right, we have time for a couple more questions here. Second to last question, do you recommend retention pins to avoid the component moving around too much?
Yes, retention pins are always recommended if you use SMD components or THR components. It's always better to have those pins to fix them on the PCB because the reflow oven is moving a little bit and you have small vibrations because of the chain of the oven, and it can be a small issue before soldering. So those pads are always recommended.
All right, and our last question for today's Würth Elektronik webinar, and then we're going to wrap it up. Is there a reduction on current capability due to 75% solder filling?
No. Though the THR components are suitable for the same ampacity than the THT components, there is no difference.
All right. Well, thank you so much, Stefan, for presenting today's Würth Elektronik webinar. It's great to have you back and talking with us about very new technology. And I remember we were talking about this last year, and I was pretty excited about it. So this is really great to have you on today's webinar. Thank you.
Thank you very much, Amelia.
And thank you, everybody, for joining us for today's webinar, partnered with DigiKey Electronics. Now, as a reminder, if we didn't get around to your question today, or even if you don't agree to an answer. We do have one of those coming in. We'll make sure that we reach out to you, webinar team at we-online.com. Simply look for an email from us and you'll get the presented materials and any questions that we might have missed. Don't miss our next webinar coming up next week on the 10th, retrofitting for industrial IoT using Wi-Fi. You can register online at www.we-online.com/webinars. And you can also listen to most of our webinars on the Würth Elektronik What's Up podcast. And it's streaming on all major networks, including Spotify, iTunes, Google Podcasts. Anywhere you listen to a podcast, you will hear the Würth Elektronik What's Up podcast. I'm Amelia Thompson. Thank you for joining us for today's Würth Elektronik webinar. Until next time, I'll see you later.